Dear students, welcome to the paper Graph Theory. I am Munira Hashim, working as an Associate Professor at Unis College of Engineering and Technology, Kollam. This presentation is made to assist my students of 5th semester Computer Science Department with the KTU paper CS 309 Graph Theory and Combinatorics, and all concepts are explained based on the textbook Graph Theory by Narsingh Dew. What is graph theory? It is a branch of discrete mathematics that deals with the study of graphs. Then, what are graphs? Graphs are a means to represent the relationship between any two physical quantities in a pictorial way. Or, in other words, we can say that graphs contain dots or points called vertices, which are connected to each other by means of straight lines or curved lines called edges. Why do you have to study graph theory? Learning the concepts and formulas of graph theory will help us to solve a wide spectrum of real-life problems. For example, real-life problems pertaining to areas like road traffic, train routes, chemical bonds, nervous system, telephone lines, computer networks, etc. can all be converted into graph theoretic problems using the concepts of GT. That is, the real problem is depicted in the form of a graph. Once the problem is defined by means of a graph or mathematically, we can check whether a solution exists or not using the formulas of GT. We can clearly state if a solution exists or not on the grounds of theorems and their proofs. Again, the GT formulas help us to find out the number of solutions for a given problem. And finally, we can find out all the solutions. Looking back to the evolution of GT, we see that the Königsberg Bridge problem pertained since years until in 1736 the famous scientist Leonhard Euler solved it using graph theory. Hence was born the beautiful paper graph theory, and Euler became the father of graph theory. For the next 100 years, nothing much happened in the field. Later, in 1847, G.R. Kirchhoff developed theory of trees, which is also a part of graph theory. Now, focusing on to the first module of our syllabus, we have two major topics, the introductory concepts and the paths and circuits. Under the introductory concepts, we shall see subtopics like graphs, applications of graphs, finite and infinite graphs, incidence and degree of vertices, isolated vertex, pentane vertex, and null graph. And under paths and circuits, we need to learn concepts like isomorphism, subgraphs, walks, paths, and circuits, as well as connected graphs and disconnected graphs. Applications of graph theory. Your syllabus asks you to go through a few applications of graph theory in the first module itself. But actually, you are not going to understand much about this now because you haven't learned any basic concepts of graph theory. However, all these problems shall be reviewed once we learn the related topics. The problems that we must see now are Königsberg Bridge problem, utilities problem, seating arrangement problem, and the problem with multicolored cubes.